In this section, you continued your discussion of linear and exponential functions that you started in 2.1. And so we're going to continue exploring those definitions. So the first one is linear function. And if you'll remember, the definition that we talked about last time was that it was a growth where there's an equal difference or common difference, one might say, over an equal interval. And so now we want to sort of explore how that might look. So when we're looking at an equation, f of x equals mx plus b, this is the common form of an equation of a line. And this kind of connects back to that explicit arithmetic equation from the last module. And in this equation, the m stands for the word slope. And it's often what we talk about when we talk about as our common difference, which again, you'll remember in the last chapter, we called that d. So now we're going to start using the letter m when we're talking about linear functions as opposed to arithmetic equations. The other thing to note when you're working on linear functions is that the graph is a line. So let's draw a couple of linear functions. There's one. Here's another. And here is a third. All of these are linear functions. They are lines. Now, if we look at exponential functions, we're connecting this back again to our geometric sequences from the last chapter. And you'll often see the equations written in the form f of x equals a b to the x. And if we remember, the b was known as our common ratio, and we often use the letter r to stand for that. And again, this is what we were calling last chapter the explicit geometric equation. And the graph for this kind of function is not a line. The best way we describe it as exponential, which is not necessarily all that descriptive, but it would look something like this. We would call this an exponential curve. Now that exponential curve can be up higher or lower, but it has this growth where it starts off kind of flat and then gets higher and higher really fast.